Yes, this is the Trieste. This is the Trieste. I heard you very well.
Yeah, Trieste, over.
On January 23, 1960, two men set out to do the unthinkable. Aboard the Bathyscaphe Trieste, Jacques Piccard and Don Walsh began their descent to the deepest point on Earth, the Challenger Deep. Descending at 1 meter per second, the pressure outside the vessel increases by about 6 atmospheres per minute, relentlessly pressing against the steel hull. As the Trieste descends deeper and deeper, the darkness gives way to something unexpected. A group of bioluminescent creatures moving past the viewport, their lights blinking like stars in the night. Moments later, at roughly 30,000 feet, a sudden loud bang echoed through the vessel. One of Trieste's plexiglass viewports cracks under the immense pressure of the deep ocean. At a time when the world was gearing up for a fierce race to reach the moon, one man looked in the opposite direction, toward the deepest part of the ocean. That point, known as Challenger Deep, is a massive pit in the Mariana Trench, approximately 40 miles long and 2 miles wide, located about 200 miles west of Guam in the western Pacific Ocean. It was first identified in 1875 by the HMS Challenger using a weighted rope, marking the earliest known measurement of the ocean's deepest point. But the one who would really take a decisive step to reach those depths was Jacques Piccard, an experienced inventor known for his pioneering work in the sky. In the early 1930s, he had already made a name for himself with high-altitude balloon flights into the stratosphere, providing the first accurate measurements of radiation from space. After previously working on a bathyscaphe, the FNRS-2, which suffered damages during testing in 1948, Piccard began designing a new and improved bathyscaphe in Trieste, Italy, with funding from the Italian government and support from the University of Trieste. Following the design phase, Auguste and his son Jacques began construction on the Trieste in the Cantiere San Marco shipyard in 1952. Measuring 50 feet in length, the Trieste consisted of a float chamber, a large blimp-like cylinder filled with gasoline used for buoyancy. This choice of liquid was strategic, as gasoline is lighter than water and is not significantly affected by deep sea pressure. At the very bottom, a pressure sphere was attached to the main cylinder. The pressurized sphere was made out of steel and measured 7.1 feet in diameter and could accommodate 2 people. In addition, a ballast system consisting of iron shot was also installed. To ascend, electromagnets would release the ballast, allowing the craft to rise. For propulsion, electric motors were placed on the upper cylinder, which allowed the sub to maneuver horizontally. With the bathyscaphe already built, it was time to test its durability and capabilities under real conditions. It was first tested in the Mediterranean Sea, where Auguste and Jacques conducted a series of dives to gradually push the limits of the vessel's capabilities. In 1953, the Trieste achieved a depth of 10,335 feet, a new dive record at the time. These early dives validated the sub's design and demonstrated its operational safety. The success of these tests attracted the attention of the U.S. Navy, who saw strategic potential in the vessel. In 1958, the Navy purchased the vessel and consulting services from the Piccards for $1 million. The Trieste was transferred to the Naval Electronics Laboratory in San Diego, California, where it was modified for even deeper dives. One key upgrade was the installation of a new pressure sphere, manufactured by Krupp Steelworks in West Germany, designed to withstand the crushing pressure found at the deepest part of the ocean. Unlike the Piccards, who were driven by science and exploration, the U.S. Navy saw the Trieste as a Cold War asset, useful for advancing submarine warfare, sonar, and deep-sea research. At a time when the US and the Soviet Union were locked in a race for technological supremacy, it was a tool to test pressure-resistant materials and assert control over a vast, unexplored underwater frontier. After acquiring the Trieste, the U.S. Navy appointed Korean War veteran Don Walsh as officer in charge, who began working alongside Jacques Piccard. Together, they tested the sub on several dives off the coast of Guam. After modifications for deeper dives were completed, the Trieste was ready to push its limits again. To ensure safety and reliability, it completed 8 test dives, starting with 2 in the harbor and then several near Guam under the code name Project Nekton, named for the vessel's ability to navigate freely like nectonic marine animals. On November 15, 1959, the Trieste nearly reached the bottom of the Nero Deep in the Mariana Trench, descending to 24,000 feet. This dive showcased its remarkable ability to explore the ocean's most extreme depths. Building on this success, the Trieste embarked on its historic final dive. On January 23, 1960, the Trieste was piloted by Jacques Piccard and Don Walsh to Challenger Deep. During the descent at around 30,000 feet, the crew heard a loud bang. Confused, the two began searching for the source of the sound. Upon inspecting the sphere, they discovered that one of the rear acrylic windows had developed a slight crack under the immense pressure. At that depth, any compromise to the sphere could be fatal. But since they were still alive and the damage appeared minor, they chose not to abort the mission and continued their descent. After a free fall of 4 hours and 47 minutes, the Trieste landed on the ocean floor at a depth of 35,814 feet. When the Trieste finally settled on the ocean floor, it stirred up clouds of fine white silt, later identified as diatomaceous ooze. Don Walsh described the visibility like trying to look through a bowl of milk. At the bottom, Piccard believed he saw a flatfish and other life forms like sea cucumbers. However, some of these sightings were later disputed, as no flatfish have been confirmed at depths beyond 27,000 feet. After 20 minutes on the ocean floor, it was time to head back to the surface on a journey that would last 3 hours and 15 minutes. After the historic dive of 1960, the Navy modified the vessel and used it in the Atlantic Ocean on several missions, most notably on the mission that located the missing nuclear submarine USS Thresher, which we discussed in our Titanic video as the submarine wreck that Robert Ballard surveyed in the 1980s in his quest to find the missing wreck. A few years later, in 1966, the Trieste was returned to San Diego and taken out of service. In early 1980, it was moved to the Washington Navy Yard, where it is now on display at the National Museum of the U.S. Navy, alongside the Krupp pressure sphere. More than 40 years would pass before anyone would ever plan an attempt to reach Challenger Deep. In 2005, film director and deep-sea aficionado James Cameron began planning and designing a custom-built submersible with the goal of becoming the third person to reach the bottom of the Mariana Trench. Cameron was a seasoned diver, having completed multiple dives to the Titanic and even the Bismarck battleship, resting nearly 16,000 feet beneath the ocean's surface. In collaboration with Ron Allum, an Australian engineer and submersible expert, and supported by a group of engineers and scientists. The project was privately funded, primarily by Cameron himself, with some partnership from National Geographic and Rolex. The team began designing Deepsea Challenger, a custom-built submersible with a unique vertical design. Just like on the Trieste, the heart of the sub was a thick steel sphere. Decades later, the sphere was still the ideal shape to distribute pressure evenly in the deep ocean. Deep Sea's sphere would accommodate one person and would feature a very small dome port, 3.5 inches in diameter. In total, it took 3 years to complete, a meticulous process to ensure it could withstand the pressure at 35,000 feet underwater. The sub was strategically designed to dive vertically, enabling a faster descent and reducing travel time to the ocean floor, time that could be spent exploring. Cameron and his team weren't focused on setting a depth record. Their goal was to explore the bottom of the Mariana Trench. To support this mission, the sub was equipped with cutting-edge technology, including a manipulator arm for retrieving samples, a sample tray with push cores for collecting sediment, a payload bay for scientific instruments, and 2 3D cameras, one mounted on the boom and the other on the manipulator arm. Once finished, the sub's pressure sphere was secured to the frame using straps. Although the departure deadline was approaching, the team ensured everything was thoroughly inspected and tested. The sphere, constructed with 2.5-inch thick steel walls, was tested in a pressure chamber at Pennsylvania State University to verify its ability to withstand the required pressure of 114 megapascals, or 16,500 pounds per square inch. To aid in the descent, the sub carried 1,100 pounds of ballast weight, allowing it to sink at nearly 5 miles per hour to the seafloor. This ballast was later released to enable the ascent to the surface. Before heading out for sea trials, Cameron sought final approval from an expert. There was no better person to consult than Don Walsh himself, whom Cameron invited to inspect the Deepsea Challenger. In early 2012, Cameron began testing the Deepsea Challenger, starting in the harbor and then progressing to deeper waters off the coast of Australia. Before initiating the dive, Cameron would spend over 2 hours inside the sphere while still on the surface, where temperatures could reach up to 100 degrees Fahrenheit. During this period, the team faced major setbacks, some of which almost led to the cancellation of the entire mission. On the 4th of February 2012, the team tragically lost 2 members.
Director James Cameron has paid tribute to an Australian filmmaker and his American colleague who were killed in a helicopter crash south of Sydney.
Andrew was flying his own helicopter with American filmmaker Mike Degree when it crashed just after takeoff on this tiny airstrip at Jasper's Brush.
Cameron referred to them as his deep sea brothers, praising their shared spirit of exploration. Undeterred, Cameron decided to continue with the mission in honor of his 2 lost friends. The team headed to Papua New Guinea for further testing. On the first dive, the Deepsea Challenger reached a depth of 3,251 feet, just about a tenth of Cameron's ultimate goal. But the team celebrated the successful completion of their first true dive without incident. On the following dive, the sub descended to 12,164 feet, and then to a record-setting 27,000 feet at the bottom of the New Britain Trench. During some of the dives, Cameron heard loud noises coming from the hull, but recalled Don Walsh's advice: if you hear loud noises and have time to think, you'll be fine, allowing him to continue the dive with confidence and peace of mind. With all the tests completed, Cameron and his team were ready to face the ultimate challenge. They sailed 1,300 miles north to Challenger Deep. This trench is so deep that even if you stacked Mount Everest and 2 Burj Khalifas on top of each other, you still wouldn't reach the surface. When the team arrived at the dive site, they encountered bad weather, a result of postponing the dive by a month. During the first test dive, strong winds caused the Deepsea Challenger to swing and spin out of control, breaking several ropes in the process. On March 26, 2012, James Cameron and his team prepared for a landmark dive, nearly 36,000 feet below the ocean's surface. It would be the Deepsea Challenger's 10th dive, and with a tight deadline. They had no choice but to begin at night and in rough weather. At 4 a.m., Cameron entered the sub and began final preparations. Although the craft had completed several test dives, this mission was unprecedented, and the team harbored concerns about the risks. Once the surface flotation bags were released, the Deepsea Challenger began its descent, plunging like a torpedo at a speed of 426 feet per minute. During the journey to the seafloor, Cameron remains in a crouched position, methodically working through a long checklist to ensure everything is functioning correctly before reaching the bottom. At 20,000 feet, he passes the point of no return, beyond the reach of any rescue, as no other submersible on Earth can dive that deep. And yet, there are still 15,000 feet to go. When the sub reached a depth of 34,000 feet, Cameron released some shot to slow his descent. After a 2-hour and 36-minute dive, half the time it took the Trieste 52 years earlier, the Deepsea Challenger reached the bottom, 35,754 feet below the surface, just 18 meters shy of the Trieste. This was because the location was completely new, about 1.5 miles away from where Piccard and Walsh had landed. Cameron began collecting sediment samples from the ocean floor using the sub's robotic arm, which featured a Rolex Deepsea Challenger watch attached, demonstrating the timepiece's impressive deep-sea diving capabilities. James Cameron described the ocean floor as a flat, desolate, and featureless plain. After 3 hours at the bottom with so much more to explore, it was time to head back to the surface. Cameron dumped his weights and began his ascent. More than 5 decades after the Trieste's historic dive, he became only the 3rd person to successfully reach the Challenger deep. Following the dive while being transported back to the U.S., the Deepsea Challenger was severely damaged in a cargo ship fire, ending its use for further dives. The following year, it was retired and donated to the Woods Hole Oceanographic Institution for educational purposes. Both the Trieste and Deepsea Challenger show how disciplined engineering and rigorous testing are vital for deep-sea exploration. Their thick metal pressure spheres evenly distributed the ocean's crushing forces, a design proven safe over decades. Even in the 1950s, Piccard and his team followed core principles: strong, pressure-tested materials and spherical hulls. In contrast, in our previous video, we explored the dangers of deviating from these principles. The Titan submersible, which relied on carbon fiber, a material far less tested under extreme ocean pressures, suffered from limited validation and potential design shortcuts, ultimately leading to its catastrophic failure in 2023. Yet despite such setbacks, the hunger for exploring the deep ocean has only grown. New and safer submersibles are still being developed. One example is Triton Submarine's $40 million deep-sea vehicle, Limiting Factor, the first commercially certified full ocean depth submersible. Designed with state-of-the-art technology, it follows in the footsteps of the Trieste and Deepsea Challenger, using a thick Grade 5 titanium pressure hull that can safely carry 2 people to the bottom of the sea. This was demonstrated on April 28, 2019, when Victor Vescovo descended to a depth of 35,869 feet, surpassing the Trieste's world depth record by about 39 feet. The dive revealed a surprisingly rich marine ecosystem, including amphipods and sea cucumbers, challenging earlier views of the trench as barren. On a later dive to Challenger Deep, Victor and oceanographer Dawn Wright stumbled upon pieces of plastic and a beer bottle.
It's a bottle. It's a freaking bottle.
Isn't that something?
It's a bottle.
Highlighting the impact humans leave behind, even in places far beyond our reach. During the 5 Deeps expedition, Vescovo explored horizon deep in the Tonga Trench, the second deepest known place on Earth, with a depth of 35,509 feet. He believes it may contain even deeper sections. Who knows? Perhaps one day we'll discover a place deeper than Challenger Deep. These impressive achievements, however, are not without risk. Exploring such extreme depths always involves enormous challenges and inherent dangers, as I showed in my recent video about the Titan submersible incident, in which the company behind the operation ignored key safety standards, ultimately leading to a tragedy. You can check out the full story of OceanGate in our last video covering the Titan disaster and its aftermath. If you enjoyed this video and want to see more content like this, please give it a like and consider subscribing to the channel. As always, thank you so much for watching, and we'll see you in the next video.